Hey there, welcome back to my channel. In this video, we will discuss about clean architecture and what kind of problem it is solved by clean architecture in practical. There are tons of tutorials are available out there, but I can assure you after this tutorial, you will get the understanding why the clean architecture is necessary in practical way using Node.js and TypeScript. Let's understand what is clean architecture. Clean architecture is a software design philosophy introduced by Robert C. Martin. We know him as Uncle Bob. The clean architecture concept is coming from his book. It's called Clean Architecture, a Craftsman's Guide to Software Structure and Design. You can read this book to get a clear understanding of the clean architecture, or you can go to this blog that is called cleancoder.com and you can read about the clean architecture right here. So these are some of the things we are going to discuss in our video tutorial, and we will be implement all these things in practical way using Node.js and TypeScript. So now we know the clean architecture is a software design philosophy, but how this philosophy gonna work, right? So clean architecture is used to create software system to make it modular, maintainable, and independent of external framework, database, and user interfaces. The clean architecture often organizes the application into concentric circle or layers. You might have seen this circular diagram plenty of times in the internet. So let's have a deeper look at this diagram and try to understand the circles which is marked in the different colors, right? The innermost layers are having more critical business logic, and each successive layers are dealing with the more peripheral concerns. The layers are pretty self-explanatory. You can see like the innermost layer, that yellow one, which is having the enterprise business rules, where we can say like all the entities in terms of maybe product, maybe user, or maybe something else, all right? All those things, it will be reside in the core of that specific layer, right? And the another one is that is called the use cases, which is marking as the use cases right here, where we will be having application business rules, where all the business rules are how exactly we will be perform the business logic right here, which is going to perform on the top of the entities, right? And the green one, you can see this is a kind of interface and adapters, you can say, all right, which is going to expose to that specific output from our business logic, right? Or from our entity to outside world, right? So this is how it's gonna work. Like you can see like in this diagram here in the corner, while our controller is coming to our user input, like controller is coming right here and it is giving some input to perform some operation, all right? Then use case, this specific layer is performing some operations like maybe calculating or maybe storing some data or maybe fetching some data. Then it is giving back to the user use case as a kind of output, right? And that output is hooking back to the presenter, right? So where in this layer, like the third layer, we can keep our controllers and our presenters and everything and right there. So this is how it's gonna work. And so the last circle is a blue one. It is referred as a kind of framework and drivers, right? Which is you can refer to Express or maybe all the web framework you can consider right here. So this is how this layer circle is representing each and every layer. To implement this layered architecture in the practical, we need to understand the main principle of the clean architecture. So let's try to have a look, right? So these are the main principles right here, or maybe you can just go ahead here also take a deeper look. So these are the same things you can look at here, which is we have adapted from the blog.cleancoder.com, right? And let's try to understand like what exactly all these principles are saying. So first principle says like independent of the framework, the core business logic and the rules should not depend on the framework or external tools. This is allow for flexibility in the choosing and changing the tools without affecting the core business logic, right? So while you are changing the framework, it should not supposed to affect your like the core business logic or core business rule. You should not supposed to touch the entity, or you should not supposed to touch the application business logic also. Second principle says the business rules can be tested without UI, database, web server, or any external elements, right? So that means while we are trying to test this use case, right, the application business rules or maybe the core business rule, it should not supposed to be involve any kind of presenter right here, right? We should not supposed to use any kind of presenter. It should have to be straightforward, testable from here, right? Let's have a look in the third principle. It says the independent of UI. The UI can change easily without changing the rest of the system. A web UI could be replaced with the console UI, for an example, without changing the business rule. So that means while you are trying to change that specific UI here in the blue circle, then it should not supposed to affect the rest of other layers. Today you are using Express as an example as a kind of UI framework, right? So tomorrow, let's say we are deciding to not to go with the Express. Let's use something else. Let's say use this Koa or maybe something else, right? So in that case, the rest of all the layers has to be unchanged. only just we are replacing that specific UI framework, right? Then it has to be work accordingly, right? And independent of the database. So you can swap to Oracle, SQL, Mongo, or any kind of database. You should supposed to change it, right, at any point. So while we are changing the database, it should not supposed to be affected our use case or entity or maybe something else, right? You can easily change that the outer layer, which is a blue one, right? Framework or drivers, right? And the last one, it says like independent of any external packages or entity. In fact, your business rules simply don't know anything all about the outside world. So that means like while we are dealing with some kind of the outside entity, as an example, while you are performing some operations in the application business rules, just like sending email or maybe making a payment or maybe just like notifying something with the help of message broker, at the time this specific business rule it shouldn't supposed to be aware about like what exactly going on outside right there, right? So we don't care about the any external packages, whatever you are going to be implement, you can replace at any time. But the business logic has to be work as it is. As an example, send an email, send the email only, right? So we don't care about you are going to send it through SendGrid or maybe mailer or maybe something else also you are going to use, right? The use case has to be like only we're sending an email, it has to work as it is. We simply just changing that, it's gonna work as it is, right? It shouldn't supposed to be affected that the core logic of the or it should not supposed to be affected the application business rule. I know there are a lot of talks, all right? I think I just made you people bored, so I don't want to make you bored anymore. Now we are straight away going to the source code and we will check it out right before clean architecture, what kind of problem we are facing, and right after implementation of the clean architecture, how that problem is go away. So that is we will check it out. All right, so this is our source code. So let's have a look at this application, right? So this is a very simple backend service, which is a kind of express application we route here, right? This is our router. If you go to the router here, and you can see there are a couple of endpoints we're exposing here, right? So where we will be creating product, get product, and update the product stock, right? And if you go to the controller here, and you can see this is a kind of product controller where we are simply creating the product here, right? And we are accepting the request and we are inserting all the data in the database, right? And we are notifying to the specific promotion service, like there is a kind of new product has been arrived. We are just notifying to the message broker, right? It's a kind of mock message broker, you can say. And finally, we are returning some kind of response to the client, right? So while our routes are calling, right, create product, then it is like calling this specific function from our controller and giving back the data. And similar way, also get product also doing the same thing, right? So where we are connecting to database and querying some data from our database and giving back that specific response. And update product stock also doing the similar kind of functionality. We are connecting to the database. We are receiving the inputs, right? And we're updating that specific data in the database, right? And sending an email, because while we are updating the stock, then we need to send an email to the product owner, let's say. Then we are returning the data from here, right? Now, can you see this is very simple application, right? So while we are having this database connection, there is a kind of connection also there, which is called PG client. If you go to database client right here, and where we are just creating a client here, right? And if client is doesn't exist, then we are just creating a new one. And if it is exists, we are returning from here. These are the helpers where we are sending emails and notifying to the message broker, right? And the index file is like doing the similar way. Since this application is very tiny and it doesn't have any problems, right? Because if you're gonna spin the application, let's try to spin the application. First of all, I'm gonna install all the dependencies, right? Then yarn dev. Yes, it is spinning in port 9000. Let's go here in the HTTP request file, right? This one. And here we are just trying to make a call here. Now, can you see we have sent a request right here, and it is giving back like the product has been created. If you go to call that specific request right here, let's say I'm going to click on the get products, we can see we have the two products are here, right? And if we try to update the product, right? So let's say try to select that specific ID as a tree. And here I can see like stock is 100, right? So let's try to use the product number 3 and send a request. Then can you see like stock has been updated. It's working correctly, right? Now we can see this is very simple application, right? So we have one Express app here, and we have our routes, we have our controllers, our database connection and helpers, everything is already. As we have seen, like, our endpoints are working correctly. Like whatever we just try to get it done with the help of this very simple API, we can able to create the product, get the product, update stock, everything is doing well. Then where is the problem? The problem is here. Our web or the UI framework, presenters and the business logic and the core business logic, everything is like, it's messed up together. Everything is tied up together. If you can see here, so this is our Express app, which is we are considering as a kind of web framework here, the most outer layer that is in the blue color here. And the presenter, which is routers, which is we are considering these routes, all right? This is exactly this layer, like the green one, where we are writing our controller, presenter, whatever you can say, right? That specific thing is here. And if you go to the create product, this one, right? So here, where we are writing all the business logic, right? So eventually we don't have that specific entity also, right? So everything's we are just like, tied up together. Maybe we are just creating a couple of files and the directories. That is not the way exactly we are just try to structure our code. The structure or maybe layered architecture, it is not about only just creating a couple of file directory structure, all right, and make it nested and move the files here and there. That's not the thing, right? It's all about like how we can make our code testable. You can see in this application, this is not testable at all, right? Eventually, if you wish to test the whole business logic, then you need to start from here, from our Express app. Only we can test our whole business logic here, right? This is what exactly it's not recommending by the clean architecture. Right now the problem is like everything is tied up together. If we used to change that specific notification service here, what we need to do? We need to go here. We need to write some changes right there. Let's say we are using RabbitMQ, then here we need to place our Kafka, right? And the similar thing, if we wish to change the email as well as an example, this one, if you go here, let's say we are using SendGrid, then we need to use something else, some other mailer, the services, then we need to replace it here. So technically what it is going to do, like while you are changing anything, then you need to touch everything. Eventually this database as well as, let's say here, this is exactly we are using PostgreSQL. If you go here in the PG connection right here, right? So this is kind of Postgres, and in future if you wish to use the MySQL, then definitely you need to use this client as well as, and go to the controller. And this is because this is exactly tied up with our business logic. So I remove everything from here and replace it here. So this is what exactly it's totally like problematic, right? So this whole project, the whole source code is not exactly as expected as per the clean architecture. So how we can solve the problem? So what we need to do, we need to segregate all these things into different layers, right? As I said, it's like, implementing layered architecture. It's not all about just creating a couple of files and directory and move it here and there. It's not like that. It's all about like we need to comply all these principles, like independent of the framework. It has to be testable, independent of the UI, independent of the database, and independent of any external package or entity, as I said like this, right? So let's try to implement all these things in a practical way, right? So I have already attached this whole repository in the description below. So maybe you can get it like there are two directories. One is before clean architecture and one is after clean architecture. We have a couple of dependencies that is we need to look into, because here in this application we are dealing with our database also, because we are using PostgreSQL here. So we have the one Docker Compose file also, which is you can spin up your Docker container by using certain port number and certain credentials are here, right? And we have our migrations also here. So go inside this migrations directory, go to SQLs, right? And click on here in the app one, which is called init tables. You can get all the query, which is going to be help us to create the product table, right? And we have one makefile also, which is going to run the whole database migrations from here, right? That is we can do. This is the .env file and the credential which is being used right here in the DB connection, right? So this one. Then let's take a quick break, and in the next episode we are going to refactor our code base and we will implement the pure clean architecture to resolve all these problems. All right, then see you in a bit.